Let me see. So hello, everyone. Thank you for having me to this conference. It's very great to be here. I'm Jong Won. I'm the VP of Manufacturing and also one of the co-founders here at Amegy. And today I'll be talking about the energy transition and more specifically towards how we could use ammonia as a future fuel. So to give a little bit of a brief background of myself and the company, so I come from a material science background. I received my PhD back in 2017, and after a few years of industry experience, three other co-founders and I decided to start a company. So here at Amegy, we are focusing on developing a ammonia power pack that can use ammonia as a fuel, basically extracting electricity from a fuel source, which is ammonia. So the company was founded in November of 2020. And so it's been a little bit over 2.5 years. And up to date, we were able to raise 220 million US dollars. And under our roof, we currently have 170 enthusiastic employees that is razor focused on delivering a first product to the market. Our main base of operations is currently in Brooklyn, and we're expanding into Houston area to build our first manufacturing plant and also expanded laboratory. We currently have two global offices, one in Norway and one in Singapore, and both of them are focused on business development. So to kind of zoom out and kind of seeing the broader picture, all of you are already aware, there's a lot of emphasis going towards renewable energy and decarbonizing the entire sector. However, if you think about renewable energy, a lot of the first candidates that come to mind is solar, wind, and geothermal, which has some limitations both in spatial and temporal availability. So looking at the supply where the renewable energies are available and the demand where the energy is actually consumed, we see a little bit of a mismatch between the two. And if we look back on the past 20 years and growth of clean tech, in the early 2000s, a lot of the emphasis were really geared towards on harvesting energy from a renewable source. So we wanted to generate energy from a renewable source so that the economy is sustainable. But around 2010, we saw some limitations in renewable energy, and many started thinking, we need a better solution to make this economy sustainable. So a lot of the funding and interest also went into energy storage. And we see that evident trend, and when we see electric vehicles, and which can be better represented as battery technology. However, as you might already been seeing in the EV industry, there's a lot of passenger vehicles and maybe light duty vehicles that is available in the market, but we don't see a lot of heavy duty transportation applications. And the main reason for that is the battery has a relatively lower density compared to carbon fuels, which really limits their applications in heavy duty industry. So in order to solve that gap in the heavy duty industry, which can be represented by maritime, heavy duty transportation, stationary power, and aviation, people started looking into hydrogen, and thus a lot of interest went into developing hydrogen economy. Hydrogen itself is a very appealing fuel source in the respect that it is clean and it has a high energy density. However, there are also some shortcomings when we use hydrogen as a fuel. You basically have to be very close to the source where the hydrogen is generated. And that is because there's a lot of storage cost and transportation costs when moving hydrogen around. So for instance, if you look at the hydrogen cost in California, it's currently about $20 per kilogram. However, if you look at the production cost of hydrogen, it's about $3. So about 3/4 of the cost is really coming from storage and transport and logistics. Hydrogen also requires, in order to be sustainable, it requires a heavy infrastructure. So these are hydrogen on-site generation and hydrogen like fueling stations. So it is very difficult to justify all of the capital investment cost when we're trying to adopt hydrogen into the economy. And so people started thinking, what kind of hydrogen carriers can be available in order to solve that gap. And one of the strong contenders for a hydrogen carrier is actually ammonia. So ammonia itself, it has several very appealing aspects. It has a very high energy density even compared to liquid hydrogen. And also at relatively moderate pressure, it can be stored as a liquid under ambient temperature. If you think about hydrogen in a liquid state, it requires cryogenic storage, which adds the storage cost and also infrastructure cost. But probably the most appealing aspect about using ammonia as a fuel is the fact that it is really abundant. It is the second most largely produced chemical in the world. And we actually have been using ammonia as a fertilizer for over 100 years. So ammonia is really traded as a commodity, like similar to oil and gas. And so there's like over 200 ports worldwide that is dealing with ammonia on a daily basis. They're operating, transporting, and there's a lot of already skilled labor that is familiar with ammonia. So the infrastructure is already there, but then there's a question of how do we convert ammonia into electricity? And that is where our technology really comes in. So there are a couple of ways to extract ammonia and electricity from ammonia. You can do some sort of co-combustion. One of the inherent, I guess, shortcoming of co-combustion comes from the fact that ammonia has low flammability. So you need some kind of a supporting fuel to sustain the flame itself. And also, then there's a question of how do you treat NOx emissions coming from the co-combustion. So Amogy's approach of using ammonia as a fuel source is actually a bit different. And it's rather simple if you kind of lay it out on paper. We basically fuel ammonia into a catalytic reactor where it cracks ammonia into hydrogen and nitrogen. And we fuel that hydrogen and nitrogen gas mixture into a fuel cell so that the fuel cell can generate electricity. So to be fair, this technology is not very new. I mean, people have been using this technology and this kind of chemical reaction in the industry for the past couple of tens and 100 years. But our main value proposition is the fact that we can actually make this process in a very compact footprint to the point that where you can actually onboard this solution on a vessel or a vehicle. So in the next couple of slides, I would like to kind of highlight the trajectory that we have been working on and what kind of technology advancement we've been able to achieve in the past couple of years. So our first demonstration actually happened about 2 years ago. When we first started operations, it was around May or March of 2021. And so we really focused all of our resources into demonstrating this 5 kilowatt drone. So it took us about 4 months to put this together. And currently you have the ammonia tank that is storing the ammonia and fueling ammonia into a reactor. And the reactor converts ammonia into hydrogen and nitrogen. And after it goes through a couple of balance of plants that supports the overall reaction, it goes into a fuel cell that generates power for the drone. If you look at how big a conventional 5 kilowatt tracker looks like, you can see like there is a big difference on and how much we can make the process more compact. So this was kind of our first step when we were entering, but we always knew that ammonia is more appealing when it goes into more heavy duty applications. The drone can be powered by a battery. I'm sure you'll lose some flight time because the battery being less dense of an energy, but there are ways to go around that. So what we've been focusing on after this demo is really scaling up our technology. So the next demonstration we performed was on an actual John Deere tractor, and we electrified this tractor using a fuel cell, and the power output was about 100 kilowatt, and this was done in May of 2022. The tractor was fairly interesting in a sense that we actually brought it up to a farm that was already using liquid ammonia as a fertilizer. So it kind of brought around the full circle where you had ammonia production in some offsite where it gets transported into a actual local farm, and now you can use that ammonia not only to fertilize your crops, but you can also decarbonize your farm gear. And the latest demonstration we performed was of course another scale up in the power scale. This was done on a Class 8 semi-truck, which is one of the biggest heavy-duty transportation you'll see on a highway vehicle. And so this roughly outputted about 300 kilowatt, and this was done in earlier this year. And in this demonstration, we not only try to focus on scaling up, but we also did a lot of technological advancements in trying to put that into a confined footprint and try to fit it under the form factor that the truck already had. So now you can see from a drone, it was made out of like plastic tubes, and now from a tractor, you have some parts that is sticking out of the tractor, and now we're getting closer to a final product that actually looks and feels and functions like a normal truck. So what are kind of the next steps for Amogy? Well, we are currently working on making a first ammonia powered ship. So this is a very exciting step for us in a sense that up until now, a lot of the product demonstration has been really focusing on the scale up itself. And while this demonstration is also going to be a scale up, it also ties in very closely to our MVP, which is a minimal viable product. So once this demo is completed, we will be focusing on developing our first product based on the engineering lessons we learned from the ship. So we actually purchased a tugboat earlier this year, which is sitting in a shipyard in Kingston, which is about 4 hours away from New York City. And we're currently working around the clock to really put everything together and make this first sale happen within 2023. So some of you might be wondering, why are we focusing on the tugboat? Why are we focusing on trying to bring this into maritime industry. Maritime industry is very conservative, but at the same time is also very innovative. So there's a lot of regulatory push from the regulatory agencies, such as the IMO, which is the International Maritime Organization, which really set a goal to decarbonize the maritime sector 40% by 2030. And this is a very ambitious goal that they're presenting. And so this kind of regulatory change really pushed a lot of the ship owners scratching their head, saying, well, I have this big ship that I need to operate over 24 hours, even like a couple of days, and I don't have a viable solution to decarbonize this. So they're looking into a lot of renewable fuels, and ammonia being an energy dense material and in a liquid state, and it's readily available. A lot of the ship owners are actually looking into decarbonizing their fleets using ammonia. So there's several different aspects that are working in our favor. You have the regulatory body that is pushing for this decarbonization, and you have a fuel source that is really abundant and available to us. We just need a means to generate power from that fuel source. And that is why people are looking into ammonia co-combustion. That is why Amogy is also looking into converting ammonia in a clean way. The other industry sector that we're really excited is actually stationary power generation. And this can be anything from like a small genset to a large scale gas turbine that operates with ammonia. There is a very high global interest in using ammonia for power generation. And the scale is absolutely mind-blowing. There are countries that are willing to look into and invest in ammonia so that they can power the entire nation using ammonia. So these are countries like Singapore, Korea, and Japan. And there are many more. I believe there is going to be many more countries that will be looking into this solution. So that kind of gives you our company's trajectory and our steps forward. And to summarize, the mission statement for Amogy is we're building a technology that can unlock ammonia's potential so that it can be used as a clean energy source in a very hard to decarbonize energy sectors. And thus we're hoping to accelerate the global journey to net zero, and which will allow future generations for a sustainable future. So thank you very much for listening to my talk. I hope this was something new and exciting for you. And I'm happy to answer any questions.